Okay guys, welcome back to some more practical guidance for the physics AQA paper. This is P1.2, the electricity topic, and the practical you've got to learn is the difference between series and parallel circuits. So I've got a set of equipment set up here, and hopefully you can remember a couple of things that are different about these two circuits. On the left hand side here, I've got our series circuit. Series circuit, just like TV programs, is where you've got one light bulb straight after the other. In other words, you're going to make the electricity, the electric current, and we know that is electrons moving through the circuit. We're going to make those electrons move through one light bulb after another. So the current flow is going around this series circuit and has to go through all three light bulbs, the current, before it can get back to the power supply to complete the circuit. As is always the case with every electrical circuit, I'm going to try and look at the three characteristics. I'm going to look at the voltage, the current and the resistance. The voltage and current I can measure. I've got my voltmeter and my ammeter, which allows me to measure those. And if I use the Ohm's law equation, which we've used many times before, V equals IR, I can always work out the resistance. However, in this particular circuit, what I'm trying to do is compare my series circuit with a parallel circuit. Now, if you can remember parallel in maths, we always talk about parallel lines that never meet. And if you have a look at my circuit here, you can see that I've set up a parallel circuit with my light bulbs all parallel to each other. Obviously I join them at the end to complete the circuit, but these, you can see that from the power supply, as the electricity comes in and goes through the circuit, it can go through just one bulb and still get back to the power supply. So we say they're all connected in parallel. It doesn't have to go through one light bulb and then the next one. Okay, you need to know about the difference between these two circuits. So I'm going to turn the power supply on now and it becomes fairly obvious. So if I click the power supply on now, you can see a difference straight away. They are both connected to the same power supply, so they both have 6 volts being provided by the power supply, but clearly the light bulbs are brighter in one than the other. The reason for this, and this is something you should be aware of, is that in the left circuit here, the series circuit, I'm trying to make the potential difference from the power supply, the 6 volts, go across all 3 light bulbs. Effectively what they're doing is sharing the energy between them. And because they've got in this series circuit, the resistance provided by that thin piece of wire inside the light bulb is being multiplied by a factor of 3. It's having to go through one, through the second and through the third. So that resistance is combining. That increased resistance is slowing the flow of the current, and as a result the light bulbs are much dimmer. One thing you need to know about a series circuit is if I take out any of the light bulbs, if I take out one, it breaks the circuit and none of the other light bulbs will work. So the circuit must be complete. We know that from lower school, from Key Stage 3. And in a series circuit here, as soon as one light bulb goes, the circuit is broken. Not ideal for your lights at the home, because as soon as one light bulb goes out, they'll all go out. But it is how often Christmas trees are wired, because it's cheaper. And as a result, sometimes when one light bulb goes in your Christmas tree, the rest go out as well. So that's series circuits. The parallel circuit is a different situation altogether. What we have here, we know electricity is about the flow of current coming into the circuit here. When the flow comes into this part of the circuit, they are electrons, they are particles, and they can't separate and divide, and they don't have personalities, so effectively they spread evenly. Some of the current is going to go through one light bulb, some current goes straight ahead, and some will go through the third one. Effectively, when the electric current gets to a junction, it splits. So if I have a current of, say, 3 amps coming through the wire, coming into the circuit, when it separates here, I'll have 1 amp going through each of the light bulbs. When it comes back to the other side, it joins up and goes back to its circuit. A parallel circuit has the advantage, obviously, of being brighter. The reason being here is because the potential difference at any one time from the power supply is only going across one light bulb. The current doesn't have to flow through all 3. Because I've got a potential difference of the 6 volts across one light bulb, it's a lot brighter. Here, if you remember, the potential difference had to go across 3 light bulbs, and as a result, it's much dimmer. As you can see from here, I've got 3 light bulbs, and interestingly, if I take one out, because the power supply is connected to all 3 light bulbs, it doesn't matter if I remove one. The others stay just as bright as they were before. That's because they still have the 6 volts, the potential difference of 6 volts going across them. If I pop it back in, we're back to where we were before. One thing worth remembering just before we go, every time you have an electrical circuit you have to connect ammeters and voltmeters. Remember, ammeter measures the flow of the electric current, and for that reason we have to put the ammeter in series with the circuit. You can see here I've got the current coming from the power supply and through the circuit and back again. So I've got a circuit here. Ammeters always go in the flow. Voltmeters, if you remember, always measure potential difference. And if I want to measure the potential difference, I've got to measure before and after my device. And so the voltmeter is always connected across the circuit. It's never part of the circuit, it's an addition, and because I put it in across the circuit, we say that this too is in parallel. So voltmeters go in parallel, ammeters go in series. And that is series and parallel circuits.